In this video, we're going to continue working on quadratics, focusing on intercept form. All right, let's do a quick review from our last lesson. Look back at the notes from last time, pause the video, and see if you can fill in all these blanks. Okay, so for general form, you should have gotten this. Ax minus h, don't forget your squared, plus k. So in general form, you have to have the squared outside the parentheses. Remember, for it to be a quadratic, there has to be an x squared term, and we're going to get our x squared term by FOILing this out. All right, if we are given this particular quadratic, what will the vertex be? All right, remember that the x value of the vertex, that h, is always the opposite of what's in the parentheses, and the k, the y value, is exactly like it is. How about the axis of symmetry? Remember, the axis of symmetry is a line, so you should have a line equation, x equals 3. Do not just write 3. You need to have the whole line equation. All right, what do we determine from vertex form? Well, there are two things that we can find from vertex form. The vertex obviously comes from vertex form, right? We found it with h and k. And the axis of symmetry also comes from vertex form because the axis of symmetry goes through the vertex. Okay, we are going to skip this one. This one is a review of vertex form. We're going to skip this one to do together in class. And we are going to skip down to this box. So flip over to the back page of your notes, and you'll see this box where it says graphing in intercept form. Let's put that intercept formula that we had on the very first page, fill that in again. From intercept form, we can tell the x-intercepts. It's going to be the opposite of P and the opposite of Q. And then both of those are x values, so the y value for those points is going to be 0. All right, let's investigate just for a moment why that is. So if I have this as my quadratic function, okay, remember we said a quadratic function has to have an x squared, but if you FOIL this out, do you see that first times first is going to give me x squared? So this one is going to have an x squared term. This intercept form is also what we call factored form, and we're going to be doing a lot of practice with factoring. So when we factor things, we end up with two linear things, and they're going to be in the parentheses. That's why we can say that it's quadratic, because x times x, those two linears, would multiply together to give me an x squared, which is what makes it quadratic. So to find the x-intercept, you remember to find the x-intercept of any function, x-intercepts occur on the x-axis, and on the x-axis, every y value is equal to 0. So basically, we're taking this function and setting it equal to 0. And then you might remember from Algebra 1, we take each of these individually and set them equal to 0 to solve that. So I'm going to get x plus 4 equals 0 and x minus 5 equals 0. And then in order to get x by itself, I do the opposite. So I end up with an x value of -4 and also an -4, and also an x value of +5, which is the opposite of what I had to start with, right? I had +4 in the parentheses, so my intercept is at -4. I had -5 in the parentheses, so my intercept is at +5. And I could write both of those as points, and those would be my 2 points. Okay, now before we go on to the next one, do you remember the synonyms for x-intercepts? What did we write down means the same thing as x-intercept? Well, we could call those roots, we could call those solutions, and we could call those zeros. Remember, we call them solutions because that's the solution that we get when we set it equal to 0, which is why we call them zeros. Okay, so my zeros, my roots, my x-intercepts, those are at -4 and 5. Okay, let's try the other one. So on this one, again, I'm going to set it equal to 0. And I'll set both of the linear factors equal to 0. So 2x minus 1 equals 0, and x minus 9 equals 0. You may be wondering why I'm skipping over this 1/2 right here. Well, is it true that 1/2 equals 0? No, 1/2 does not equal 0, so we don't write that part down. We only write the ones that have the variable in it. So this one has an x, this one has an x. So both of those we're going to set equal to 0. All right, and then we're going to solve, working to get x by itself. All right, and let's solve this one. Get x by itself on that one. So I have two solutions, or roots, or zeros, or x-intercepts. And that's the points 1/2 0 or 9 0. Okay, so that's why when we do the formula, in the original intercept form, it's x minus p, but the x-intercept is at p, comma 0, right? It's the opposite of what I have in the parentheses. All right, so how do you know if a graph opens up or down? And what does that even mean? Well, for a graph to open up, it's going to go this direction. And for a graph to open down, it's going to go this direction. It's basically telling us where the open part of the graph is. The open part is on the upper side, and here the open part is on the lower side. So we'd say that this graph opens up and this graph opens down. And that comes from the A value. Make yourself a note of that. Remember that A that was in front of the parentheses, that tells us whether the graph should open up or open down. So if A is greater than 0, if A is positive, the graph is going to open up. Well, that means that this one, if I were to graph it, this one would open up because I have a positive A value of 1/2. If my A value is less than 0, if my A value is negative, then the graph is going to open down, which means that this one would open down because my A value is -3, which is a number that is less than 0, so therefore the graph is going to open down. All right, let's put all that to use to graph this particular function. So I see the format that it's in. I don't see a parentheses squared. I see two different sets of parentheses. So that tells me that this one is in intercept form. Well, the vertex is a little bit harder to find in intercept form. I can't just pull it off the numbers like I could in vertex form. So I'm going to have to type this one into my calculator, and I'm going to do second trace. After I graph it, I can determine if this one is a maximum or a minimum. So look, this one has a 3, which means it's positive. It's going to be opening up. So the vertex right there, is it going to be a maximum or a minimum? Well, it's going to be a minimum because it's on the lowest part of the graph. This one will not have a maximum value. Okay, so type that in your calculator and do second trace and look for minimum. What you're going to find is that the minimum is the point -0.5, comma, -6.25. Okay, now we're not going to get panicked about the fact that we see some decimals there instead of integers, right? We're just going to graph this -5, -6.25. So about there is the vertex. All right, now axis of symmetry. What do we remember about the axis of symmetry? Well, it's a vertical line that goes directly through the vertex, and we dot it because it's not actually there. The parabola is the answer. The shape that we get is the answer. The dotted line is there to just help us graph it. It's vertical, so it's x equals, and then it's -0.5. That's the x value of the vertex. That h value is what goes right there. And we already said this one is a minimum. So my minimum occurs at the point -0.5, -6.25, and there is no maximum because this is going to go up forever in both directions. So far we have a vertex and we have the axis of symmetry, but we need more points on the graph before we can connect the dots to make the parabola. So let's find our x-intercepts. So if we look at our original function and set it equal to 0, I'm going to need to set each one of my linear factors equal to 0, and I get x equals 1, which is the opposite of the negative 1 I got right here, and x equals negative 2, which is the opposite of the plus 2 I got right here. So my x-intercepts are at the points 1, 0, and negative 2, 0. All right, so 1, 0 is right here. Negative 2, 0 is right here. And you can see that each of those points is 1.5 units away from the axis of symmetry. Because they're on the same horizontal line, they should be the same distance away from the axis of symmetry, and they are. Okay, now y-intercept. Do you remember how we found the y-intercept? We plug 0 in for all the x's. And we can probably do this one without our calculator as well. 0 minus 1 is negative 1. 0 plus 2 is 2. 3 times negative 1 is negative 3. Times 2 is negative 6. So my y-intercept is at the point 0, negative 6, which is here. All right, and if I have one half a unit away from the axis of symmetry on this side, I need one half a unit away from the axis of symmetry on that side as well. So now I have all the points I need to graph the parabola. All right, and I asked Desmos to do that for me because it usually does a better looking job than mine. However, Desmos does always forget the arrows that go all the way up on the two sides there. Okay, so now increasing intervals. Do you remember from before? Increasing means going up, and as we go to the right, this whole part of the graph is increasing. So I'm going to increase from this point forever to the right, and this point is the x value. X equals negative 0.5. That was the vertex. And then I will increase forever to the right, which means I'm going toward positive infinity. All right, decrease is this side. Remember, we read our graph from left to right, so even though that arrow is pointing up, I'm going this way when I read the graph. This whole piece of it is decreasing, and it decreases until this point, which again, that x value is negative 0.5. So I'm going to decrease from negative infinity to negative 0.5. All right, positive. Remember, positive means it's above the x-axis, so I have two intervals. This first one from negative infinity to negative 2, right, because I'm only reading the x values. And then the second one over here, that's a positive 1. It's halfway in between 0 and 2, 1 to infinity. And I've got the union in between them to show that I'm putting those two sets together. I only have one negative interval. You see, I can draw the whole thing without picking up my pen. So my one negative interval is from negative 2 to positive 1. All right, how about end behavior? As x approaches negative infinity. Okay, that means we're going this way. So as x approaches negative infinity, you can see that my function is going forever up. So that's going to be positive infinity. And as x approaches positive infinity, that means I'm going this way. And again, you can see that as my graph goes to the right, it is also going forever up. So I'm going to say it approaches positive infinity on that side as well. All right, how about domain? Remember, domain is all the possible x values from left to right. So farthest to the left that this graph goes. Remember, this arrow is going up, but it's also going left. So my domain starts at negative infinity, and it goes on and on forever to the right, which is positive infinity. If you write from positive infinity to positive infinity, that means you didn't actually go anywhere. So make sure you've got negative infinity, positive infinity. Now the range. The range is going to start here, and it's going to move up forever. So what value should I write right there? Well, that's the y value of the vertex, and it's going to go on and on forever up. My arrows tell me on and on forever up to infinity.